Before we do this binary division problem, let's once again ground ourselves by looking at it in decimal, looking at a decimal division problem. So let's divide 951 by, how about 6? So what do we do here? Well, we just kind of start digit by digit and see if 6 will go into that digit or that number. So 6 will go into 9 one time, right? So 6 times 1 is 6, and then 9 minus 6 comes out to be 3. Then we drop down the next digit, right? We drop down this 5. Does 6 go into 35? Yes, it does. And almost, right, if it was 36, it would go in 6 times. So that must mean it goes in 5 times. And so 6 times 5 is 30. And so we take 35, subtract 30, and that leaves us with 5. Then we drop this digit down, and we have 51. So how many times does 6 go into 51? Well, 6 times 10 is 60. 6 times 9 is still too big, so it must be 8. So 158, and so 6 times 8 is 48. And we subtract these guys, so we can't take 8 from 1, so 4. So 11 minus 8, right, is 3, and 4 and 4 is 0. So what do I end up with here? We could keep on dividing this and get a decimal thing, but we're not going to do that. We're just going to kind of give the 4th grade answer and say that this is our remainder and this is our quotient. I'm not going to write out quotient because I'll probably misspell it. So that's just a refresher of kind of what goes on here. Now, let's see what happens in binary. Can we fit the sequence 1, 0, 0 in 1? No, we cannot. So that's a 0. Can we fit it in 1, 1? Well, here, so 1, no. So then we drop down this 1. Can we fit it in 1, 1? Right, no, we cannot. Can we fit it in 1, 1, 0? Yes, we can. And spoiler alert, it's always going to be yes, it can, 1 time, or no, it can't, so 0 times. So, because our answer has to be binary. So it goes in 1 time. So let's write down 1 times 1, 0, 0, which is just 1, 0, 0. And subtract them. So 0 and a 0 is a 0. 1 and a 0 is a 1. And 1 and a 1 is a 0. And now let's drop this 1 down. So now how many times does 1, 0, 0 go into 1, 0, 1? Or in effect, basically what we're asking in this binary case is our divisor, right, this 1, 0, 0, smaller than our partial quotient, I guess we could call it. I'm not sure what we'd call this. And in this case, this is smaller, so we can go in there once. And we get 1, 0, 0. So let's subtract these guys. So 1 and a 0 is a 1, 0 and a 0 is a 0, and 1 and a 1 is a 0. Now let's drop this guy down. So can we go into a can 1, 0, 0 go into the sequence? No, it cannot. So we're going to put a 0 here. And now we drop down this 0. Right? We drop down this 0. And now we say 1, 0, 0. And what do we get here? Well, do our subtraction. We end up with 0, 1, 0. And it can go in once there. So we write our 1. And it looks like here we've got our quotient. And we've also got our remainder. So these might be two things that go into two separate registers. Right, this is one thing that goes into memory, and this is another thing in memory that you might be able to look at. Sometimes you might do a modulo division where you'd look at one or the other. But yeah, so that is how we do binary division. And there are some cases when you might carry things out to further and further decimal places, but this is just kind of straight, unsigned, nothing special binary division.